Hello everyone, I am Vinay Kumar. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my YouTube channel, you can visit the playlist section of my YouTube channel, and in that playlist section, you can find different playlists for science and maths videos starting from 8th standard till 10th standard. So in future, I will be teaching physics, chemistry and mathematics of 11th and 12th as well. So as of now, I am teaching 10th standard mathematics. In that 10th standard mathematics, I was teaching 6th chapter in 10th standard mathematics that was based on triangles. In my previous videos, I have explained you what do you mean by similar figures, what do you mean by similar polygons, and also what do you mean by similar triangles. And I have also solved the examples and exercise 6.1 questions. So after looking into that, we discussed about theorem 6.1 and theorem 6.2. So in theorem 6.1, what we discussed was, if there is a triangle like this, if it is named as ABC, and if there is a side or if there is a line which is parallel to BC, which is intersecting A at E, which is intersecting AB at E, and which is intersecting AC at F. So if this EF line is parallel to BC line, then the ratio AE by EB is equal to the ratio AF by FC. So this was our theorem 6.1. Similarly, in theorem 6.2, if these two sides are in equal ratio with these two sides, that is AE by AB is equal to AF by FC, if AE by EB is equal to AF by FC, then EF is parallel to, then EF is parallel to BC. So basically 6.2 is the converse of theorem 6.1. So this was theorem 6.1 and this was theorem 6.2. Based on these two theorems, we have to solve few examples. So now we will move to the first example in this chapter based on theorem 6.1 and 6.2. So in this example, here there is a triangle. Let me draw that triangle over here. So there is a triangle like this, and there is a line which is intersecting this triangle in such a way that it is parallel to one of the side of this triangle. The naming what they have given for this triangle is ABC, and this line intersects AB at D and intersects AC at E. Now you have to prove that AD by AB, so that is AD by this entire length AB is equal to AE by this entire length AC. So this you need to prove in this example 1. So one data they have given here, that is DE is parallel to BC. So here what they have given is DE is parallel to BC. Therefore, according to theorem 6.1, so according to theorem 6.1, AD by DB is equal to AE by EC. So AD by DB is equal to AE by EC. So this is according to theorem 6.1. So now since AD by AB is equal to AE by EC, I'll just take the reciprocal on both the sides. I'm taking reciprocal of both the sides of equality sign. That is DB by AD is equal to EC by AE. So I have just taken the reciprocal of this. Now here I'll just add 1 on both sides. Add 1 on both sides. So when we add 1 on both sides, then DB by AD plus 1 will be equal to EC by AE plus 1. So now we will try to solve this. So here we need to multiply AD with 1. So when we solve this, DB plus AD divided by AD is equal to EC plus AE divided by AE. Because here it is EC by AE and here it is 1 by 1. So AE and 1's LCM if we take, AE will be remaining. So that AE I have to multiply here. So AE gets cancelled with each other. For 1 also I have to multiply AE. So then EC plus AE will be there in the numerator, and in the denominator AE will be there. So DB plus AD, EC plus AE is there. So now if we look into the diagram here, you can just look into the diagram. DB plus AD is there. So that is DB is this length, AD is this length. So if you add DB and AD, then you will get the total length AB. So here AB divided by AD is equal to EC plus AE is there. So EC is this length, AE is this length. So that will give you the total length AC. So AC by AE. So now we have AB by AD is equal to AC by AE. So I'm just taking reciprocal of these two ratios. When you do that, you will get AD by AB is equal to AE by AC. So this is what they had asked to prove in this example, and we have proved that. And one more thing you should remember, to solve exercise questions which are there in exercise 6.2, you need to remember this condition also. So whatever in example 1 we have solved, the same you need to use to prove certain things in exercise 6.2 questions. So that's why just remember that if you have a triangle like this, and if you name this as ABC, and if a line is drawn parallel to this third side BC, and if you consider this as D and this as E, we already know from theorem 6.1 that AD by DB is equal to AE by EC. And also from example 1, we have proved that AD, that is this length, by AB is equal to AE by AC. So this is also one condition which you need to remember while solving exercise 6.2 questions. So this example 1 also you need to remember. Now we will move to the next example, that is example 2. So in example 2 also you need to use this theorem 6.1 and theorem 6.2. So in example 2 they have given a trapezium. So now in this trapezium, two sides will be parallel to each other. So here this side and this side are parallel to each other, and there are two non-parallel sides like this. So this is a quadrilateral where this side and this side are parallel to each other, and this trapezium is named as A, B, C, D, and a line is drawn parallel to DC like this. Now you need to show that AE by ED, that is this AE by ED, is equal to BF by FC. So this is what you need to prove, but here we have triangles in theorem 6.1 and 6.2. So in order to get a triangle, you can just join A and C like this. So if you do that, this trapezium is cut into two triangles. One is this particular triangle. So one we have this particular triangle, that is A, D, C, and the point of intersection where this AC is intersecting with EF, that point you can name as G. So if you name that as G, then here you will have an EG line. So that means this triangle I am writing over here, and this EG is parallel to DC because EF is parallel to DC. DC, because EF is parallel to DC, here EG is also parallel to DC because EF is a straight line. So above this there is one more triangle, that is ACB, because we have drawn a diagonal to this trapezium and we have divided this trapezium into two triangles. So we will draw one more triangle like this. So we have one more triangle like this. This is A, this is B, this is C, and here from G to F you can draw a line like this. So this is G, this is F. Here, since A and AB and DC are parallel to each other, EF is also parallel to DC. So that means here AB is parallel to DC, that is parallel to EF. Since EF is parallel to AB, GF is also parallel to AB. So these things will write over here. So here what they have given is AB is parallel to DC. Here AB is parallel to DC. That is what they have given. AB is parallel to DC, and they have also given EF is parallel to AB. and they have also given EF is parallel to AB. Therefore, EF is also parallel to DC. That is, here AB is parallel to DC, AB is parallel to EF. So if AB and DC are parallel and AB and EF is parallel, then two lines are parallel and one more line is parallel to one of the lines. So that means it will be parallel to the third line also, because AB is parallel to DC, AB is also parallel to EF. So EF will be parallel to DC. So that means AB, EF and DC, all three are parallel to each other. So therefore EF is parallel to DC. Now what you can do is you can draw a diagonal. So draw diagonal connecting A and C. So draw a diagonal connecting A and C. So when you do that, we get two triangles, that is ADC and ABC. So in that two triangles, EG is parallel to DC, GF is parallel to AB, because EF is a straight line and it is already parallel to AB and DC. So in triangle, first we will consider the first triangle, that is this ADC. In triangle ADC, EG is parallel to DC. This is because EF is parallel to DC. Since EF is parallel to DC, EG is parallel to DC. Since EG is parallel to DC, therefore AE by ED is equal to AG by GC. That is, AE by ED is equal to AG by GC. This is according to theorem 6.1. Now in triangle, we will consider the other triangle. So in triangle ABC, here GF is parallel to AB. So why GF is parallel to AB? Because EF is already parallel to AB. So in bracket you can write EF is parallel to AB. So that's why GF is parallel to AB. So since GF is parallel to AB, here AG by GC, BF by FC will be equal to each other. AG by GC is equal to BF by FC. This is also according to theorem 6.1. So now this is according to theorem 6.1. A is by ED is equal to AG by GC. AG by GC is equal to BF by FC. So here if you call this as equation 1 and if you call this as equation 2, in equation 1 also we have AG by GC, in equation 2 also we have AG by GC. So that means AE by ED is equal to BF by FC. So here equation 2 I can write as BF by FC is equal to AG by GC. So now if you call this as equation 3, now you can compare equation 1 and equation 3. You can see RHS are equal in both the equation. So therefore from 1 and 3, equation 1 and equation 3, here what is the LHS? AE, here RHS are equal. AG by GC is equal to AG by GC. LHS is AE by ED divided by BF by FC. AE by ED is equal to BF by FC. So this is what they had asked to prove in this particular example, and we have proved that. Now we will move to the next example in this chapter, that is example 3. So in example 3 also they have given one triangle and you have to prove that this particular triangle is an isosceles triangle. The triangle looks like this. So this is a PQR triangle. So this is P, so this is P, this is Q and this is R, and ST is a line connecting from PQ to PR. So this is ST, and this particular angle and this particular angle are equal to each other. That is what they have given here. And one more thing they have given here, PS by SQ is equal to PT by TR. So what and all things they have given here, let me write that. So PS by SQ is equal to PT by TR. And one more thing they have given, angle PST is equal to angle TRQ. So this angle and this angle are equal to each other. So here since PS by SQ is equal to PT by TR. Therefore, ST is parallel to QR. So why ST is parallel to QR? This is because of theorem 6.2. So we have equal ratio, that is PS by SQ is equal to PT by TR. Since we have equal ratio, ST is parallel to QR, that is theorem 6.2. So now here, based on this result, we have to prove that this PQR triangle is an isosceles triangle. So since ST and QR are parallel to each other, this angle will be equal to this angle also because of corresponding angle theorem. ST is parallel to QR, therefore PST is equal to SQR. This is because of corresponding angle theorem. So this is because they both act as corresponding angles. So since PST is equal to SQR, and given that here they have given that PST is equal to TRQ. So here they have given PST is equal to TRQ. So since PST is equal to TRQ and we know that PST is equal to SQR, therefore SQR is equal to TRQ. So that means here in this triangle, this particular SQR angle and this particular TRQ angle are equal to each other. So here, if two angles are equal to each other in a triangle, then opposite sides of that angle will be equal to each other. That is the theorem which we have learnt in 8th standard and 9th standard. So here you can see PQR is equal to PRQ. So since PQR is equal to PRQ, here PQ will be equal to PR. So that is isosceles triangle theorem. Since SQR is equal to TRQ, therefore PQ is equal to PR, because here angle Q is equal to angle R in triangle PQR. So here angle Q and angle R are equal in triangle PQR. So therefore PQ is equal to PR. This is according to isosceles triangle theorem. So this is according to isosceles triangles theorem. So according to that, since SQR is equal to TRQ, we are getting PQ is equal to PR. So PQR is an isosceles triangle. Therefore triangle PQR is an isosceles triangle. So therefore triangle PQR is an isosceles triangle. That is what they had asked to prove in this example 3, and we have proved that. Now we will move to the exercise 6.2 questions. So now we will be moving to exercise 6.2 in this video. So in exercise 6.2, coming to the first question, here they have given two questions. So first we will focus on the first question. In first question, there they have given a triangle like this. So they have given a triangle like this, and this triangle is named as ABC. So this is A, this is B, this is C, this is D, and this is E. Here they have given the length of the sides in this triangle. So here AD length is 1.5 centimeter. So here AD length is 1.5 centimeter. DB length is 3 centimeter. EC length they have not given. You need to find the EC length, and AE length is 1 centimeter. Here DE is parallel to BC. That you need to remember. Here since DE is parallel to BC, since DE is parallel to BC, according to theorem 6.1, we have AD by DB is equal to AE by EC. So now you can substitute all those values in this equation. So AD is 1.5 centimeter divided by DB is 3 centimeter is equal to AE is 1 centimeter. EC is, we don't know EC. So now we can just bring EC to LHS. So when you bring EC to LHS, EC will go to numerator. So here 3 centimeter, when it is brought to RHS, it becomes into 3 centimeter. So it will go to numerator, and this 1.5 centimeter will come to the denominator. So divided by 1.5 centimeter. Here 1 centimeter gets cancelled with each other. So 1.5 ones are 1.5 twos are 3, because 15 ones are 15, 15 twos are 30. So 2 into 1 centimeter will be 2 centimeter. So EC is equal to 2 centimeter. So this is the answer for first question in first question. Now we will move to the second question in the same first question. So in second question also they have given one more triangle like this. So they have given a one more triangle like this, and in this triangle there is a line parallel to third side. So this is also ABC. This triangle is also named as ABC, and this point is D and this point is E. Now they have given DB as 7.2 centimeter. So here DB they have given as 7.2 centimeter. EC they have given as 5.4 centimeter, and AE they have given as 1.8 centimeter. Now we don't know AD, we need to find AD. So in this triangle also DE is parallel to BC. Here according to theorem 6.1, AD by DB, so this is AD by DB is equal to AE by EC. AD we don't know, we'll just keep AD as it is, divided by DB. DB we know that it is 7.2 centimeter. So 7.2 centimeter is equal to AE is 1.8 centimeter divided by 5.4 centimeter. This 7.2 if you bring to numerator into RHS, it goes to numerator. So 1.8 centimeter into 7.2 centimeter whole divided by 5.4 centimeter. So your centimeter gets cancelled with each other. We know that 18 ones are 18, 18 threes are 54. So if you multiply this also with 10 and this also with 10, it will become 18 by 54. So here 18 ones are 1.8 ones are 1.8, 1.8 threes are 5.4. So 7.2 divided by 3 is there. So 3 ones are 3, 3 twos are 6, point will be there, 12, 3 fours are 12. So AD is equal to 2.4, and here 1 centimeter is there, so 2.4 centimeter. So the value of AD is 2.4 centimeter in this case, and in the first question AD was 2 centimeter. In the second case AD is 2.4 centimeter. So now in the second question in exercise 6.2, E and F are points on the sides PQ and PR respectively of a triangle PQR. So if you take a triangle PQR like this, so this is P, this is Q, and this is R. So there is a line parallel to third side. So E and F are points on the sides PQ and PR. So this is the EF. So now here they have given 3 cases in this second question. In which particular cases EF will become parallel to QR, you need to tell. So in order to do that, you can use theorem 6.2. So if you find the ratio of these two and ratio of these two, and if they are equal to each other, then EF is parallel to QR. So now we will move to the first question in second question. So in first question, PE they have given us 3.9 centimeter. PE is equal to 3.9 centimeter, and EQ they have given as, so I'll write all the 4. So PE, EQ, EF and FR. So here 3.9 centimeter is PE, EQ is 3 centimeter, PF is 3.6 centimeter, and FR is 2.4 centimeter. So this is in the first question. So now we will take PE by EQ. So PE by EQ means it is 3.9 centimeter divided by 3 centimeter. Centimeter gets cancelled with each other. 3 ones are 1.3. So 1.3 is the ratio. Now PF by FR. So take PF by FR. So if you take PF by FR, then it will be 3.6 centimeter divided by FR is 2.4 centimeter. So your centimeter gets cancelled with each other. So here 12 twos are 24, 12 threes are 36. So 2 3 by 2. So 2 ones are 2, 2 1.5s are 3. So 1.5 is the ratio. So therefore PE by EQ is not equal to PF by FR, because here P by EQ is 1.3, PF by FR is 1.5. So those two are not equal to each other. Therefore here EF is not parallel to QR. So your EF is not parallel to QR. So that is what we need to tell, whether EF is parallel to QR or not. Now we will move to the second question in the same question. Here again you have to take the values for PE, EQ, PEF, FR. So here PE in the second case is equal to 4 centimeter. EQ in this is 4.5 centimeter. PF in this case is 8 centimeter and FR is 9 centimeter. So now we will take PE by EQ. So take PE by EQ, that is equal to 4 centimeter divided by 4.5 centimeter. So here 4 by 4.5 will be there. I can write this as 40 by 45. So now 45 ones are 45. 45 point we have to take 400. So 45 8s are 360. So 40 will be remaining. Again 8, again 8. So like this it goes on. Now the ratio of PE by EQ is 0.888 and it goes on like that. Now we will take PF by FR. So when you take PF by FR, that is equal to 8 by 9. 8 centimeter divided by 9 centimeter. So 9 ones are 9, 9.80. So 9 8s are 72. Again 8 will be remaining, 9 8s are 72. Again 8 will be remaining, 9 8s are 72. So here also it goes on like 0.888. It goes on like this. In both the ratios, if you see, it is equal to 0.8888 and it goes on like that. So that means here both the ratios are equal to each other. Therefore PE by EQ is equal to PF by FR. So therefore here EF is parallel to QR. So therefore EF is parallel to QR in this second question. So now we will move to the third question in this second question. So in third question they have given PQ. So now I'll just draw the diagram one more time over here. So this is P, this is Q, this is R. So here this is EF. We have to say whether EF is parallel to QR or not. So here PQ they have given, that is 1.28 centimeter, and PR they have given. So PR is equal to 2.56 centimeter. So after that they have given PE as 0.18 centimeter. So PE as 0.18 centimeter, and they have given PF, that is 0.36 centimeter. So PF is 0.36 centimeter. So now we have to find out. So they have given PE and PF. We need to find out EQ and FR. So in PQ, if you subtract PE, you will get EQ. So PQ is equal to PE plus EQ. So we know that PQ is 1.28 centimeter, P is 0.18 centimeter plus EQ. So 0.18 if you bring to LHS, it becomes 1.28 minus 0.18, which is equal to EQ. So 1.28 minus 0.18 will give you 1.1. So therefore EQ is equal to 1.1 centimeter. Similarly here only I'll write in the other side, PR is equal to PF plus FR. So what is PR? PR they have given us 2.56. PF they have given us 0.36. So 0.36 plus FR. So here 0.36 if you bring to LHS, it becomes 2.56 minus 0.36 is equal to FR. So therefore FR is equal to 2.56 minus 0.36, that will give you 2.2. 2. So now we have got EQ and FR. So now we will take PE by EQ. So PE by EQ, what is PE? PE they have given as 0.18. So 0.18 divided by 1.1. So this you can write as 18 by 110. So you can write this as 18 by 110, or else you can just write this as 1.8 divided by 11. So 11 ones are 11, 11 ones point you have to take, 11 ones are 11, 7 will be remaining 70. So 11 6 are 66, 4 will be remaining 40, 11 3s are 33, 7 will be remaining. So again it will be 6 3 6 3. So it goes on like this, 0.163636363 goes on like this. So this number recurs. So now you can take PF divided by FR. So what was PF? PF they had given here as, here if you see, PF they have given as 0.36 centimeter. So 0.36 divided by FR we have calculated here, that was 2.2. So if you solve this, you will get 3.6 divided by 22. So here 2 11s are 22, 2 1s are 2, 1 will be remaining 0.8. So we are getting 1.8 by 11. So here also 1.8 by 11 was there, here also 1.8 by 11 is there. So if you solve this, you will get 0.16363 and it goes on like this. So here both the ratios, that is PE, EQ, PF, EFR are equal to each other. Therefore, PE by EQ is equal to PF by FR. Therefore, here EF is parallel to QR, and this is according to theorem 6.2. So this is all there in this particular video. I have solved 2 questions of exercise 6.2 and I have solved example 1, 2 and 3 in this video. So the remaining questions in exercise 6.2 that I will be teaching in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard to 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.